All right, let's talk about something that feels a little bit like magic. Natural language processing, or NLP for short. This is the science, the art, really, of teaching computers to understand and actually use our language. It's a huge task, and it's fascinating.
I mean, have you ever stopped to really think about it? You ask your phone a question, you tell your smart speaker to play a song. How does it get it? How does it know what you're talking about? Well, that little piece of everyday magic, that's NLP at work.
And the funny thing is, you're using it all day, every day. Think about it. Siri, Alexa, Google Translate working its instant magic, those customer service chatbots. NLP is just completely woven into the fabric of our digital world.
Okay, so let's get the official definition down. At its core, NLP is all about a computer taking our messy, complex human language and somehow turning it into a structured format that it can actually work with. It's all about finding order in the chaos of how we talk. But this is where things get really tricky. Because the single biggest reason NLP is so challenging is that our language is just fantastically, wonderfully ambiguous. What seems crystal clear to us is like a minefield of confusion for a machine. So, let's take a look at a classic example here. Just 4 simple words. I made her duck. I mean, it sounds pretty straightforward, right?
Well, hold on a second and just think about it. How many totally different meanings can you pull out of that one little sentence? Go on, take a guess. 2? Maybe 3?
You're not going to believe this, but there are at least 5. Let's run through them. It could mean you cooked a duck for her, or maybe you cooked the specific duck that was hers. You could have built her a little toy duck, or, completely differently, you made her physically duck down. And hey, if you're feeling a little whimsical, maybe you magically turned her into a duck. That's 5 totally different scenarios from just 4 words. Wild, right? And that right there, that's the whole game. The entire mission of NLP is to create systems that can look at a sentence like, I made her duck, and, based on the context, figure out which of those 5 realities is the right one. It's all about solving that ambiguity. And what's so cool is you can see exactly where the confusion comes from. The word duck, is it a noun, the bird, or a verb, the action, make? Does that mean to cook or to create? Even the word her can play 2 different roles. Every single word creates a fork in the road, and the computer has to choose the right path.
So, how in the world does a machine even begin to tackle this? It's not like it can just take a wild guess. Nope. It needs a system, a logical process to untangle our linguistic mess. Let's walk through how it does it, step by step.
This whole thing is often called an understanding pipeline. It's a series of steps. First up, you've got morphological analysis, which is just breaking words down into their tiniest meaningful pieces. Then comes syntactic analysis, which is all about grammar and sentence structure. After that is the big one, semantic analysis, figuring out what it all means. And finally, there's discourse processing, where the machine looks at the whole conversation to get context. Let's just quickly touch on those first 2.
So that first step, morphology, this is all about morphemes. And a morpheme is simply the smallest possible unit of a language that still has meaning. It's not a letter, it's a piece that means something. So for instance, a computer doesn't just see the word cars. It sees 2 morphemes, the root car plus a little tag for plural. It sees giving as the root give plus another tag for progressive. By getting these absolute basic building blocks right, it can start to figure out the grammar. Okay, so once the words are broken down, the system jumps to syntax. This is where it starts to map out the sentence, finding the subject, the verb, the object, all that stuff you learned in school. And by looking at that grammatical structure, it can start to solve our puzzle. It can figure out that in I made her duck, the word duck is probably a noun, the thing I made, and not a verb. This is a huge first step in getting rid of some of those other meanings.
So that's a super quick peek at the theory. But how did we get from these basic ideas to the crazy powerful tools we have on our screens today? Let's kind of zoom out a bit and look at how this whole field came to be.
I mean, the field has come such a long way. It really started back in the 40s with these early, clunky attempts at machine translation. For decades after that, everything was based on humans trying to handwrite millions of complex grammar rules. But the real game changer, the revolution, started in the 80s when we shifted to machine learning. Suddenly, instead of being fed rules, computers could just learn the patterns of language by themselves, just by reading massive amounts of text.
And that one shift, it unlocked this incredible explosion of new applications.
I mean, today, the field is huge. It's powering everything from translation and chatbots to systems that can pull specific facts out of a giant document, answer really tough questions, and even figure out if a movie review is positive or negative.
And the engine driving all of this today is a kind of AI called deep learning. Specifically, it's a model architecture you've probably heard of called the transformer. This is the tech behind big names like GPT, and it's what lets these systems understand language with a nuance that feels almost human.
Which, of course, brings us to the future. With things moving this fast, what's next? You know, where do we go from here with this relationship between us and our language-savvy machines?
Well, the ultimate goal has always been to close that gap, to make our interactions with computers not just useful, but totally seamless, totally natural. We want to get to a point where talking to a machine feels exactly the same as talking to another person. And that leaves us with this one last really deep question to think about. A system can predict the next word in a sentence with incredible accuracy. It can translate, it can summarize, it can chat, but as these machines get better and better at using our words, what does it really mean for them to understand? It's a question that kind of blurs the line between just computing and actual consciousness, and it's something we're all going to be grappling with for a long, long time. Thanks for joining me.